practice some more on finding domains of a functions. We've seen before that the set of valid inputs of a function is called the domain of that function. So let's find the domain of the following functions and give the answer in interval notation. So the first function, f of x equals 5x plus 4. Let's write that again in here. F of x equals 5x plus 4. So the input is called x, right? And the function is called f. And what this function does is multiplies the input by 5 and then adds 4 and then gives that as the output. In general, to find the domain of a function, we're going to start with all real numbers. So we start with all real numbers. Here will be negative infinity and here will be positive infinity. And then we are going to think about excluding any x's that will cause the result to not be valid. So is there any x that can't be multiplied by 5 and then added 4 to it? So if x is 0, I'll have 5 times 0 plus 4, that's okay. If x is 100, that's okay as well, 5 times 100 plus 4. If x is negative 1,000,000, I'll have 5 times negative 1,000,000 plus 4. So it seems like every x, so every real number is a valid input for this specific function f. So therefore, the domain is all real numbers. So the domain of f is all real numbers. And as an interval notation, because we have to give the answer in an interval notation, we write it negative infinity to infinity, both with parentheses. All right, for our second function, 2, the function this time is called g of x, and the input is still x, and it's a rational expression. So it's g of x equals x plus 3 divided by x minus 2. So let's find the domain of g. Like I said before, we start with all real numbers, and then we're going to look at any x's that would cause the result to be invalid. Since we have a fraction in here, we know that we can't divide by 0. So that means that this quantity that is the bottom of the fraction of the rational expression cannot be 0. So therefore, we must have that x minus 2 is not equal to 0. So let's see what input will cause that. So if I add 2 to both sides, I get that x cannot be equal to 2. So then let's say that 2 is here. So it can't be 2. So no to 2. 2 is not going to be part of the domain of g. So let's see if everything below 2, everything less than 2, will be part of the domain. So let's test the point. So let's test what's a number less than 2. So let's do negative 1. So negative 1 plus 3 divided by negative 1 minus 2, that's going to work, right? That gives me a number. It's a number. It's a legitimate result. What about, so therefore this whole portion is going to be part of the domain. Also, let's test the point greater than 2. So let's put 3. So to test 3, we have 3 plus 3 divided by 3 minus 2. That is also legitimate. It's 6 divided by 6, okay? So then everything greater than 2 is also going to be part of the domain of g. So therefore, the domain of g is in interval notation. I start from negative infinity to 2. And I'm going to put a parenthesis for 2 because it can't be 2, because 2 will cause division by 0. And then I put the union sign because together the domain has 2 parts, 2 to infinity. Okay, so this is an interval notation, or you can also say that just simply that x is not equal to 2. And depending on how you're asked to find the domain, both of these are correct. Okay? All right, so let's look at the last function. The last function is called h, and the input this time is called t. It's not always the case that the inputs are going to be x's, right? this could mean that the input t represents time or something. So h of t equals square root of 2t plus 10. All right, so let's write that last down. H of t equals square root of 2t plus 10. So let's find the domain of h. So let's start with all real numbers. Oops. Negative infinity to infinity. And then let's look at what inputs, t this time, will cause the result, square root of 2 times t plus 10, to be invalid. So we know that when we have square root of a quantity, that quantity has to be positive, right? Because we can't take square root of a negative number. I mean, we can, but it's not a real number. So we must have that 2t plus 10 has to be 0 or positive. Okay? In other words, 2t plus 10 has to be greater than or equal to 0. Okay, so let's see what makes 2t plus 10 0 first, and that's going to be a valid. So 2t plus 10 equals 0. Subtracting 10 from both sides, we get that 2t equals negative 10. So t equals negative 5. Okay, so for negative 5 is going to be part of the domain, because square root of negative 10 plus 10, which is square root of 0, square root of 0 is 0. It's a legitimate output. And now let's test everything below negative 5. So let's pick a point less than negative 5. So let's do negative 10. So let's see if h of negative 10 is a valid output. So this will give us square root of 2 times negative 10 plus 10, which is square root of negative 20 plus 10, which is square root of negative 10, not a real number. Okay? So this side, below negative 5, it's not going to be part of the domain. If we test anything above negative 5, so let's do h of 10, for example, we would have square root of 2 times 10 plus 10, which is square root of 30, which we know that is a real number. Okay, so the domain is going to be everything to the right of negative 5. So finally, we can say that the domain of h is negative 5 to infinity. Notice I put a bracket on negative 5 because negative 5 is a valid input. When the input t is negative 5, the output is 0. All right, so that concludes this section.